Hi everyone, welcome to Vocal Academy. So in this problem, here one PNP transistor circuit is given here. So for the circuit some data is given here and asking that how to find RC. So observe carefully the circuit. For the circuit, at emitter there is a voltage source, at base there is some resistance that is called as base resistance, and for collector some resistance is there, that is RC, means collector resistance. So here VB is given, that is base to emitter voltage drop across this point. The voltage drop is given as 0.7 volts and beta is some constant that is given as 50, and base resistance, so this is the base resistance, that is RB. So RB is given as 100 kilo ohms, and output voltage is given, that is 5 volts is given as output voltage. Now asking that how to find RC. When you observe carefully here, this is output voltage across resistor RC. Means if you know that IC value, means the current flows in this branch, that is collector current, then we can easily find RC value by applying Ohm's law, that is voltage V0 equal to IC into RC. So where V0 is the voltage drop across RC. If you know IC, then we can easily find RC, that is V0 by IC. So this is the required value, but we don't know what is the IC value, but we know V0 value. Now how to find collector current? So we need to find collector current. So if you know collector current, then only you can find RC value. So here another part is there. So from this we will get IC value. How can you get it? So from this here we will get base current, but we know the relation between base current to collector current. So first of all find the base current. So from this loop, so in this loop the current is IB, that is base current. Now apply KVL for this loop. So here the source voltage is 10 volts. So 10 volts equal to sum of all voltage drops in that loop. So here base to emitter some voltage drop is taken place, that is 0.7 volts. So 0.7 plus, now voltage drop across RB is according to Ohm's law, that is base current into the resistance RB. So from this we get current IB equal to 10 minus 0.7, then bring RB to left hand side, becomes by RB. So it becomes 9.3 by RB is given as 100 kilo ohms. By simplifying this we will get 0.93 milliamperes. So this is the base current for the given circuit, 0.93 milliamperes. Take this as capital B because base. Okay. Now recall the relation between collector current to base current. That is collector current, that is IC equal to beta into IB. This is the standard relation between these two things. Now from here we will get beta is given as 50, that is constant. So 50 into IB is, we got 0.93 milliamperes. So by simplifying this we get collector current, that's be equal to 4.65 milliamperes. So this is the collector current. Now substitute this value in this equation, then we get the required value RC, that is collector resistance, that is RC equal to V0 is given, that is 5 volts. So 5 minus round is 0 by the current is 4.65 milli. Milli means 10 power minus 3. 5 minus 0 nothing but the voltage drop across RC. Here 0 means lower potential, higher potential minus lower potential, that difference is the voltage drop across RC. So RC equal to 5 by 4.65 into 10 power minus 3. So by simplifying this we will get RC equal to 1.07 kilo ohms. So this is the collector resistance for the given problem, and this is the process of simplification. And thanks for watching. Please subscribe, like, share. Thanks.